Cool. Okay, so we're still in chapter 6, which is chemical quantities. And I just want to start off by, oops, sorry guys. I just want to start off by reviewing what we were talking about last class, so the molar conversions. Right, so molar conversions are where we're using the molar coaster. And the molar coaster, again, takes us from things we can measure in the labs, like grams, to our conversion unit, the mole, and to atoms or molecules. Whoop. Right? And going from grams to moles, what is the piece of information we need?
Molar mass.
The molar mass, that's right. Right, so molar mass. And then going from moles to atoms or molecules, what's the piece of information we need? Avogadro's number.
Avogadro's.
And that's 6.022 times 10 to the 23rd atoms or molecules per 1 mole. Okay. So we also said that there's another step that we often want to do where we want to go from moles of one thing to moles of another thing, right? If we want to go from moles of one thing to moles of another thing, what quantity do we need?
Formula subscript.
Formula subscript or the molar ratio. Right? So sometimes the molar ratio will be the formula subscript, but occasionally as we go forward into stoichiometry, it will be the ratios from the balanced chemical equation, right? So we'll talk more about that in this class. So let's do a little example. So let's say we have 15 grams of sodium phosphate, and we want to know how many sodium atoms are contained in our sample. Right? Oops. Okay. So just a little reminder there that we're going to have some nomenclature on the next exam. Right? So this is a little practice for us. So first thing we should do is find the chemical formula for sodium phosphate, right? So what is sodium's ion?
-1. Just minus. Oh, +1.
Plus one, right? Yeah, so metals are always trying to lose electrons, so they're always going to make cations. So it's going to be Na plus, right? And then phosphate, what's that guy?
It's gonna be 3 minus or -3.
That's the charge, but what are the atoms in there?
I don't know.
P.
Oh, just the P? Oh, yeah, okay.
O. 4. 3 minus.
I haven't learned the things that we need to memorize. I haven't done that.
Yeah, so there's going to be practice in lab this week. You guys are going to be doing some more nomenclature practice. Fortunately for you guys, you don't really have to memorize these guys now because you're going to be able to have the list in front of you when you're taking the exam. But you still need to be able to identify the fact that phosphate is on that list. You know what I mean? So knowing that when you see this name, that means this guy, right? So you don't have to necessarily have these memorized, but you do need to see an 8 or an ite and start thinking, oh, this must be a polyatomic, right? Does that make sense, guys? Cool. So, a reminder on doing ionic nomenclature or ionic formulas, right? So we always want to make a neutral compound, right? So how many sodium atoms will we need to make a neutral compound?
3.
3, right? For every one of these guys, we need 3 of these guys, right? So what that looks like is this, right? Now, just as a reminder, I think some students feel more comfortable putting parentheses around this because it helps them remember that this is a polyatomic ion, not just a phosphorus and 4 oxygens, right? So if you like to do that, that's completely fine, right? The parentheses become non-optional when there's a subscript out here, right? Everybody cool with me? All right, so we're starting off with grams, right? Sorry, you guys, I keep going in and out of the shot here. We're starting off with grams. So we want first to get to moles, right? So what piece of information do we need to find first?
Molar mass.
Exactly, right? So always we look for the chemical formula first because without the chemical formula, we can't calculate the molar mass, right? Does that make sense, guys? Yeah? Cool. All right, so sodium is 22.99 grams per mole, and there are 3 of them, excuse me. We have 1 phosphorus, 30.974 grams per mole. And then we have 4 oxygens, 15.998 grams per mole. So I'll let you guys calculate that out.
I got 163.94.
163.94 grams per mole. Awesome, right? So this is the molar mass of sodium phosphate, right? Okay, so I gotta flip pages. So now again, we're starting off with 15 grams of sodium phosphate. We know the molar mass of sodium phosphate is 163.94 grams per mole, right? And we want to go from grams to moles of Na3PO4, right? And then from there, do we want to go directly to molecules? Or do we need to make a pit stop? What are we looking for in the problem?
Only looking for the sodium atoms.
Right, so if we're just looking for sodium atoms, then we need to go from moles of our compound to moles of sodium, right? Then we can go to atoms. Does that make sense, guys? Cool. I think drawing out a map that kind of gives you that molar coaster, but like a straight line, can be helpful for students. It's definitely helpful for me because, like I said, I'm a visual learner, so it really helps me to see where I'm trying to go, right?
Can I just ask a dumb question?
No, it's not dumb. What's up?
Why would we find the molar mass of the entire compound if we only want the sodium? Wouldn't we just find the molar mass?
That's a really, really, really good question. Okay, so because we're starting off with sodium phosphate, right? This is the grams that we have, right?
Okay.
So if this is the grams that we have to start off with a molar mass of the thing that we have grams for in order to make this first jump. That's a great question, right? So one of the things that we haven't really talked about explicitly, but that's going to be really important, especially later on today, is when you're writing out these units, I don't know about you guys, but I'm extremely lazy, and I'm like, writing this whole sodium phosphate thing out every single time is a huge pain in the ass, and I don't really want to do it, right? But if we don't do that, it's really, really easy to forget whose moles belong to what and whose grams belong to what, right? Right now, we're only working with one compound, right? But very soon, we're going to be working with 3 to 4 compounds, right, in a chemical reaction. So things get really messy when you have multiple compounds flying around. Does that make sense? So it's really important to make sure that you're writing out the complete units, right? So this would be the complete units. So, and then we have moles of Na3PO4 up top, right? So 163.94 goes here. Right? But you can see if you're starting off with grams of sodium phosphate, you can't cancel grams of sodium phosphate with just grams of sodium. Does that make sense, Jessica? Yeah? That was a great question. That wasn't stupid at all. That's probably one of the #1 mistakes that I see students make, is they think, oh, I'm solving for this guy, so I want to go straight there, right? But you can't go straight there. You got to take the detour first. So the way that I was showing you guys how to set these problems up before was my straight line way, because I'm lazy and I like to write it all down and then do the calculations. But I think for a lot of students starting out with this stuff, doing it stepwise can also be helpful. So I want to do it that way for this problem. So instead of going a straight line from grams to atoms of sodium, we're just going to go to moles of sodium phosphate first. Then we'll calculate moles of sodium. Then we'll go to atoms. Okay, so we'll do it stepwise. So I have 15 divided by 163.94. What does that give me?
10.929.
Divided.
Yeah, 163.94 divided by 15.
Flipped it around. 15
Wait, oh.
divided, yeah.
I was like, what? 0.0915.
That sounds good to me. And that'll be moles of sodium phosphate, right? All right, so now we bring that guy down here. Oops. And our next step we want to do is to go from sodium phosphate moles to moles of sodium, right? So what unit needs to go on the bottom here?
Avogadro's number.
Not yet.
The one we just got.
Just the units, right? What unit needs to go on the bottom to cancel?
Mole.
Mole of
the compound. Oh,
Yeah.
sodium.
Yeah, sodium phosphate. No, you're right. So
the whole thing?
yeah, so I need moles of sodium phosphate on the bottom, right? So I can cancel with these guys. And then what are the moles I'm trying to get to?
Just sodium.
Exactly. So now I need moles of sodium up here, right? So looking at the chemical formula here, right? For every 1 mole of the compound, how many moles of sodium do I have? You can also think about it as for every 1 molecule of this, right? How many sodium atoms do you have? 3, exactly. Yeah. Does that make sense, guys? Jessica, you with me?
Yeah. I got lost because like I'm used to it being a complete railroad tracking. So then when you wrote equals 0.0915, I was thrown off.
I got you. I'm trying to so I know that you guys. Yeah, no. I'm sorry. I know for some people that this can be helpful doing it stepwise instead of doing it all the way across. I personally like the all the way across method, right? So that's the one that I teach you guys from the start. So if you hate this, throw it away, okay? Yeah, that's totally fine. But the steps that we're going through are still the same, right? So we would have 3 moles of sodium for every 1 mole of sodium phosphate, right? So now moles of sodium phosphate will cancel with moles of sodium phosphate, and we get 0.27 something.
0.2745
Moles of sodium. So now what am I trying to get to?
Atoms?
Sodium atoms, that's right. So I want atoms of sodium up top, right? And what do I want on the bottom?
moles of sodium.
That's right, moles of sodium. So this is where avocado's number comes in, right guys? So we have 6.022 times 10 to the 23rd atoms of sodium for every 1 mole of sodium. What you guys get?
1.65.
Yeah, 1.65
Times 10 to the 23rd? 22.
22, sorry.
I'm asking. Yeah?
Why does
20. Go ahead.
Mine says 24. I'm not sure why.
Mine says 22.
It
Mine
should.
says 23.
Mine says 22.
Okay, so let's look at the digits out front. Does everybody have this?
Yes.
Okay,
Yeah.
but we have different versions of this.
Yes.
Okay, so here's how I'm gonna I'm gonna show you my logic behind why I think it's 22 and not something else. So when you multiply this number times this number only, right? What do you get? What?
1.65.
1.65 or 0.65? Or 0.165?
1.65.
Cool. So then this is 23, right?
Yeah.
Does that make sense? So if I just multiply the coefficients together, right? Whatever I get there is going to go here, right? And then I can just bring that power of 10 down.
Okay.
Cool. So this could be, again, another issue with putting in your calculator, right? So did you get the parentheses correct? Are you using the EE function? No carets involved, right?
No carrots involved.
Cool.
No carrots were harmed in the making.
I like that. All right, and again, that's atoms of sodium, right? Sorry for that ugliness. So, what do you guys think of doing it piecemeal?
I like it better just the railroad.
Yeah, I do too. Okay, cool. That's cool. I've heard from, I think from students that don't get the dimensional analysis when we're doing it up front. I think a lot of the times they have an easier time doing it this way. But I feel like you guys really got dimensional analysis when we were doing it at the beginning. So I feel like that really sticks better this way. Cool. Awesome, Kata. Awesome. All right, cool. So we'll never do it that way again. You're welcome. Okay. Any questions about that one before we move on? All right. I'm going to stop my video.